Welcome to lesson 2. In this lesson, I'll discuss the interfacing of LCD 16x2 with Arduino. LCD stands for Liquid Crystal Display. It is an intelligent display device. Why we call this 16x2? Because there are 16 columns and 2 rows in the display window. Total, we can display 16 characters in each line. 32 characters in 2 lines. While interfacing a LCD, you need to know the connections and the details of LCD memories. Let's start with the connections. A standard 16x2 LCD has 16 pins. The pins start with 1, which is ground. 2 VCC, you should connect 5 volt here. 3 is VEE. Here we connect a potentiometer normally, so that we can control the voltage of that pin. This pin is used to control the brightness of the LCD. Pin 4 is register select. We should give 0 when sending commands and 1 when sending printable data. Command is used for the LCD settings and data is used to print what we want to. Pin 5 is read or write. Read is only required when you want to know whether LCD is busy or not. But practically, we will use ample delays. So, we'll ground it and LCD will always be in write mode. Pin 6 is used for enabling the LCD. A falling edge is required at this pin if we want to enable the LCD. Pin 7 to 14 is DB0 to DB7. This is the data port of LCD. Whatever you want to send to LCD, be it commands or data, it should enter the LCD through this data port. You can use 4 pins of this data port. In that case, LCD will work in 4-bit mode. But if you use it fully, then LCD will work in 8-bit mode. In 4-bit mode, a byte of data will enter into 2 pieces of 4 bits each. We will use this 4-bit mode while interfacing it with Arduino. Pin 15 and 16 are LED plus and LED minus. These are the pins of LCD backlight. And if that backlight is on, then LCD contents can be visible in dark. And there are 3 memories: DDRAM, CGRAM and CGROM. DDRAM is display data RAM. The size of it is 256 bytes. CGRAM is character generating RAM. Size of it is 64 bytes. Then there is this CGROM, which stores the entire ASCII table. The storage size of this memory is 128 bytes. DDRAM's location starts from 80 and goes up to FF. Normally, whatever we want to print on LCD, it gets stored in DDRAM. Look at this LCD window. The first line shows the DDRAM's location from 80 to 8F, total 16 blocks. The second line shows DDRAM's location from C0 to CF, again 16 blocks. Locations from 90 to BF and D0 to FF are not visible directly. It can only be visible if you perform a shift display operation. So LCD's window can only display 32 DDRAM locations, which is equivalent to 32 characters. CGRAM's 64 bytes are divided into 8 memory blocks with 8 bytes each. CGRAM's location starts from 40 and goes up to 7F. It is used to store custom characters like any symbol, logo, text, which are not in the ASCII table. The process is we first design the character on the basis of how it can get printed. Then we store the character in any block of the CGRAM. Then we copy the contents of the CGRAM to DDRAM, and then subsequently it gets displayed on LCD. I'll show you the process in detail later in this lesson. CGROM stores the ASCII table along with the character patterns. So we are not actually sending characters to LCD. For example, the ASCII value of capital A is 41 in hex. When we want to print capital A, we send 41 to LCD, and LCD treats 41 as a memory location and puts a query in the CG-ROM. CG-ROM then returns a pattern which looks like this capital A, and in the process, A gets printed on the LCD. All these processes are written in Arduino's liquid crystal library. The library has the following functions. For printing on LCD, we need this print function. Any string written inside inverted comma inside that print function will get printed. For initializing LCD, you need to tell the controller the LCD type using this begin function. For example, for 16 cross 2, we write begin within bracket 16 comma 2. For 20 cross 4, we should write begin within bracket 20 cross 4. It sets the blocks and lines. And there is another function called set cursor. Using set cursor, we can set where we want to print. We give column and line number inside set cursor function. Then it starts printing. For an example, if we write set cursor 0, 0, the printing will start from the first line's first block. This is a detailed process of how LCD is interfaced with any controller. So at first, you should connect the LCD in either 4-bit or 8-bit mode. In 4-bit, only DB4 to DB7 is required. In 8-bit, whole DB0 and DB7 should be connected to the controller. Then you should initialize the LCD. For initializing, you have to send commands like you have to select the 2-line display. Then you have to select the display on, cursor on, or display on, cursor off, anything. Then you can use clear LCD. By this command, the previous contents of LCD will be cleared. Then you can set RS to send data. And if you want to send command, then reset the RS pin. Copy the data at the LCD port when you are sending data. Set RS first, then copy the data at the LCD port. Then set EN, and after a few milliseconds, reset EN. This will create a falling edge, and that falling edge will trigger the LCD to accept data. You can vary the brightness of LCD using any potentiometer connected at VEE, and you can also adjust the data positions using the set cursor function. To understand the LCD better, I'll show you 3 experiments. I'll print a number, text, and a custom character. I'll write 3 different programs to show you the workings. So first, let's understand the circuit. To be very honest with you, first I shot the circuit connections video. Then I designed the circuit. Because during connections, I have connected the pins as per my convenience. So I'll incorporate the same in the code, and actually this is also a way by which some students love to do the experiments. To be what they say a versatile learner, let's learn it that way. So in my circuit, the first pin, that is VSS, is connected to ground. VDD will be connected to 5 volt. And I have connected one potentiometer. There are 3 terminals in the potentiometer. One is connected to 5 volt, another is connected to ground, and the middle one is connected to VEE. RS is connected to pin 12 in my case. RW, that pin is connected to directly ground, and enable is connected to pin 11. Now these are the pins you should remember, that 12 is connected to RS, 11 is connected to enable. Then there are these 4 pins, D4, D5, D6, D7. As I told you, I'll be using 4-bit mode. So D4 is connected to pin number 5, D5 is connected to 6, D6 is connected to 7, and I have made a random connection. So D7 is connected to pin number 4. I'll write the program that way. So let's make the connections first, then I'll show you the programming. So this is my setup. I have Arduino board, LCD, breadboard, one resistor, one potentiometer and few jumper wires. Let me show you, this is pin number 1 and this is pin number 16 of this LCD. Let me put this LCD on the breadboard. Now I'll place the potentiometer. Remember, the potentiometer will be connected to VEE, that means pin number 3. So let me connect the jumper wires. One is connected to pin number 1, that is ground. Another pin is connected to pin number 3, and this pin will be connected to pin number 2, that is VCC. And there is this pin for ground, like I'll be using the horizontal rail, and this is connected to ground. And now this is connected to VCC. This is RS, I'm connecting it to pin number 12. This is read write connected to ground. This is enable, it should be connected to pin number 11. I'll connect the D4567. According to the circuit I have shown you earlier. This is D7 and it is connected at pin number 4. Resistance, I am connecting a resistance to pin number 15 because that is the LED, so I'll apply 5 volt there. So my connection is finished. Let me connect the USB cable. So to program the LCD, first I have opened the Arduino. What I'll do is I'll go to examples and I'll find liquid crystal library. Here there is this sample program, that is hello world. This is the program I'm going to use. See, there is this library liquid crystal.h, and then there are this RS, EN, D4, D5, D6, D7, and I'll change all these pins because I have connected in different pins, so I have to mention that. And liquid crystal LCD is the object creation where we are sending the parameters. What parameters? We are sending the pins RS, EN, D4, D5 because this 12, 11, 5, 4, these are already mentioned here, and that we are sending as a parameter to this object. And then we are using lcd.begin 16 cross 2, then we are printing a simple string hello world. And in void loop lcd.setCursor 01, see, this is the column number and this is the line number. So line number 1 means second line and column number 0 means first block. So second line's first block is printing the millis divided by 1000. It's just a second counter, nothing else. So in this program I'll not print any number, so I'll comment out this line, and this is also I'm going to comment out. And here in case of hello world I'll write lcd space 16 cross 2 display. And here I'm going to change the pins because D4 I have connected, D7 I have connected at 4 and D4 at 5, this is 6, this is 7. These are my pins. So this is the simple program to display LCD 16 cross 2 display. First let me select the Arduino port. Now let's upload my program. Yes, it's uploaded. Now you can check the output. See the display. It's LCD 16x2 display. Now I think that printing a string is understandable. So now what I'll do is I'll change this thing. I'll comment out the string and rather I'll start printing the number. So I have enabled the second counter and enabled the set cursor. Now without changing much to this program, I'll again upload it and I'll show you the output. Yeah, it's uploaded. Now you can check that the number is continuously increasing. That is the second counter. It's like a second watch. It's getting incremented every second. This is how we print a number. So let me show you that instead of this millis and thousand, I can write anything like I can define a variable and I can use a formula and I can calculate a particular number, and then instead of millis divided by thousand, I can directly write the variable's name and that value will get printed on the LCD. This is how we normally print number on LCD. Now I guess you have understood it. Now I'll show you how we can print a custom character. So for custom character, let me open the browser. I want to show you something. First, what I'll do is LCD custom character generator. I'll search for it and I'll click on the first link that is coming. So this is actually a graphic image where and there is a program behind this web page. So here I'll design a character. Design a character means I'll simply design a battery symbol. Now battery charging symbol is not the thing that is on the ASCII table. So this is how a normal battery symbol looks like, and this is half filled, like half charge left. So if this is the symbol we want to print, so here I have designed this. You can also open this web page and design your own symbol, and automatically this web page is generating a code for Arduino, and this is the code. Now here one thing I must tell you, that the darker greens, these blocks means 1. So 0 1 1 1 0. See, 0 1 1 1 0, 0 1 1 1 0, 0 1 1 1 0, and see 0 1 1 1 0. This is how it is getting calculated, and these are the bytes we want to store in CGRAM, and later on we will print it on DDRAM. So LCD create char means this particular thing is copying all the bytes into a CGRAM's memory location, and then LCD.home means it will get back to DDRAM's first location. Then LCD.write means it will copy the contents of this CGRAM memory location to DDRAM. This is how it is getting printed. So what I'll do, and you should also do, is just copy the code. Copy. Then I'll open my Arduino. Sorry, let me open the blank sketch, and here paste the code. Now let me save it. LCD custom char. I have saved it. Now here so here 5 6 7 and 4, and this is the byte LCD dot write 0. Here I'll LCD dot set cursor. I want to give a memory location of DDRAM. Like, I don't want to print from the first block, I want to print from the 8th block of first line. So LCD set cursor, LCD dot write. Now let me upload this program to my Arduino. Everything else is perfectly okay. Now let me upload. Yeah, there is this error. You can also get this error, but don't worry, just write UINT T. You should typecast this UINT, sorry. This is how we typecast this. Now we can upload. Yeah, it's uploaded. Now you can check the output. See, battery symbol is coming. So in the next lesson, I'll show you how to interface servo motor with Arduino.